I'm delighted to be here with you today because we are at a transition point in human history when we are using our incredibly powerful new capabilities of the genetics and biotechnology revolutions to renegotiate in profound ways our relationship with the world around us. Our species now has the increasing ability to recast the code of life. And the essential question that will determine our future is whether or not we can use this power wisely. Conversations like this are so essential because every one of us and all of our institutions have a critically important role to play in this process. To set the stage for where we are, it's important to understand the magnitude of this moment in history when one of the greatest forces in the universe, human creativity, is being unleashed. 100 years ago, 2 billion people lived on our planet with a roughly 15% literacy rate. That means that around 300 million people had the opportunity to fully participate in the world of knowledge shared beyond their immediate communities. Today, there are nearly 8 billion of us with an 85% literacy rate, meaning 6.5 billion people can share their ideas. Because we are networked with each other, everyone can wake up every morning and solve new problems, ending the wasteful redundancy of innovation our ancestors experienced. Because our technologies are super converging with each technological revolution inspiring and being inspired by all other technologies, the tools we are using to understand and interact with the worlds within and around us are improving at exponential rates. And because this change is accelerating, we must continually challenge the evolved practicality of our brains to help us understand what's coming. We must, in other words, all start to think a little like science fiction writers, because we live in a world that will increasingly feel like science fiction. As exciting as this all is, it can also be unsettling, not least because it feels unnatural to many people. But we need to remember that much of what we call natural is not fully natural, at least as experienced by our ancestors. Our distant ancestors never went hiking in the woods for fun because the woods were full of dangerous predators. They wouldn't recognize almost everything in our supermarkets today, including almost all of the fruits, vegetables, and animal products. So the issue for us in our world engineered by our ancestors using the technologies of their day, like the then radical biotechnology of agriculture, is not technology yes or no, but technology how best to benefit humanity and our world. We also need to recognize that while healthcare is a critically important driver of our application of our new genetics and biotechnology capabilities, this revolution extends far beyond healthcare. We are moving from a paradigm of generalized medicine based on population averages to our new world of personalized or precision healthcare, where interventions are made or not made based on a far deeper understanding of each person's individual biology. But collecting genetic and broader systems biological information as part of our transition to precision medicine, and placing those data in ever larger and more usable databases along with other biological and life information will allow us to use our increasingly powerful tools of AI and machine learning to begin to crack the code of complex life. We'll never understand it perfectly, but even our imperfect knowledge will shift us toward a more predictive model of healthcare, health, and in many ways, life. Our goal will be to optimize and then expand our biological possibility with continuous feedback loops guiding precision interventions at the optimal times. We'll move from our current system, which we call healthcare, but is all too often symptom-based sick care, to a truer model of prediction and prevention. But as I said, the genetics and biotechnology revolutions will and must extend far beyond human health. They are already leading us toward very significant and badly needed changes in how we do agriculture. The green revolution of last century is what made it possible for us to go from 2 to 8 billion humans so quickly. But its reliance on chemical fertilizers and engineered water systems is simply not sustainable in our current form as our global human population grows toward an estimated 10 billion people. Chemical fertilizers today account for 2% of energy use and 1.5% of greenhouse gas emissions. not to mention the impact of runoffs to sensitive aquatic ecosystems. We are reaching the limits of sustainable land and water use for the course we are on. Clearly, we need to increase yields while lowering agriculture's environmental and climate footprint. Our new tools, like the ones LEAPS is championing, promise to do just that by doing things like manipulating the microbiomes in plant roots and soils to massively decrease the need for fertilizers and pesticides, and generating crop varieties that can thrive in highly populated parts of the world where climate change-induced warming and groundwater salination are threatening current crops and human survival. Of course, this is not all about new technologies. We also need to invest in helping traditional agriculture become more sustainable and scalable. The question is not technology either or, but how best. Our value chains will only be valuable if they are sustainable. The incredible economic growth we've seen over the last 150 years has depended on levels of extraction that are not infinitely scalable. To grow economically in ways that don't decimate our planet, we must shift our natural resource acquisition model from cut down and dig up to grow, using precision fermentation from genetically engineered yeast, algae, and bacteria and other approaches to do what nature already does, build from small to big from the recipe of code. This is the revolution of biology plus biology-inspired human engineering, where we can grow plastics, woods, fabrics, industrial enzymes, and many of the other raw materials we need. McKinsey estimates that 60% of all physical inputs to the world economy can be disrupted in this way. DNA data storage is another important area where we simply must think differently using these new tools. We are today on the verge of generating far more data than we can store with our current technology. But DNA is the ultimate data storage mechanism, honed over billions of years. It's 1 million times denser than silicon and can be stored for over 1 million years. New frameworks for DNA data storage and computing have the potential to be an important foundation of our information future. Of course, there are significant challenges of science, cost, and scale in all of these areas which must still be overcome. But human creativity is essentially infinite, while most of the existing natural resources on our planet are finite. There are also very real potential dangers which must be acknowledged and addressed. Our technologies do not come with their own built-in value systems. It's up to us to ensure that our most cherished values guide the application of our most powerful technologies. Because what we're talking about here is manipulating complex systems we don't fully understand, which requires almost limitless humility. If we are not enormously careful, and even if we are, we run the risk of limiting the diversity of life, which has always been the foundation of resilience and survival. Given the power of these technologies, their uneven application could supercharge the massive equity challenges we already face across the globe. But we need to recognize that maintaining the status quo also carries with it existential risks, climate change being only one. There's a danger in not investing in healthier lives for ourselves, our loved ones, and the people around the world, in not seeking a more sustainable future for our planet, in not beginning to imagine alternative long-term futures for our species when we know this planet will not always be habitable. But to increase the odds that we use our technologies to help us, individually and collectively, and not undermine us, we need to recognize that this is not ultimately a conversation about science, but about values. Ethics is not what we do after we've developed a technology, but a framework we must integrate into every aspect of our work from the start. It must be at the core of all processes, products, and interactions at every stage. To do this, we need to recognize our responsibilities as builders and shapers of that larger story, even if we are each only touching a small part of it. We need the strongest possible governance and accountability frameworks in our companies, universities, governments, and international organizations, dynamic processes for public-private partnerships, as well as systems for exploring and sharing best practices. We need to think differently about public education, empowerment, and engagement. by working with radical transparency, by supporting ongoing and multi-directional public dialogues where we are really listening and where what we hear has the potential to impact directions going forward. We need inclusive and respectful processes that optimize positive societal and global outcomes for all. I know this is a very tall order, but it's not just about where we are going, but how we get there. Because we are on the verge of an incredibly exciting future if we can have the wisdom and foresight to build it. And building that better future is up to each and all of us. Thank you.